This is the ECU bench testing primer. My name is Sam. When I started in automotive cybersecurity, people would go to the junkyard and actually rip apart vehicles, take the wiring harnesses out with multiple modules, and try to rewire a car on a board, if you will, which was not so useful for forensics or cybersecurity work because it was so costly and time-consuming just making something run. I decided to show that it was possible to do by getting a 2022 Dodge Ram telematic module from eBay, something random I selected. It was about $100. I really know nothing about the vehicle itself or this module until it showed up at my house. There's not a whole lot on there, no screens or lights, wiring harness, micro USB, 4 antenna inputs. And this telematics does have a cellular module, which I'm hoping is still active because it is a 2022. While the device snaps together, it is tightly secured so it doesn't rattle when you drive down the street. Taking a screwdriver and pulling at the clips does allow it to open up pretty easily. Once the device is finally open, the battery connector actually keeps the top lid on, and tugging a little bit while holding the PCB allows that to come apart pretty easily. Looking at the actual top of the device, we can see that we haven't actually voided any warranty as the sticker is still intact. For now, we'll put the lid aside and take a look at the inside of the unit. The first thing we're going to do is try to identify some of the main common components and figure out exactly what's in this unit. As I said, I really don't know much about this unit at all, aside from the fact that it came out of a Dodge Ram and it's a telematic module. Zooming in on the PCB, we can actually see the main SoC, some unpopulated components over here, 2 CAN transceivers, a transceiver for something else, power input circuitry, Wi-Fi, some other depopulated things for whatever reason. What looks to be actually an SD card footprint, what's probably an EEPROM, and we can get a close-up shot of that, and the debug connector. So that's the EEPROM, and that's the Wi-Fi chip, an 88W8887. Flipping the device over, we see the rolling wireless AR7582 module, which is powered by a Qualcomm ARM. The device specifications, which are kind of available, tell us that there is GSM, CDMA, LTE, WAN, and even GPS on this device. So it seems like a very interesting module. Flipping it over, looking at the input to the device, we can actually see the power via go into what looks to be a fuse and a diode, and one of the pins attached to the ground plane. So immediately we've identified the 12 or 13 volt input and the ground inputs. A little to the middle there, we can actually see the CAN transceivers, pins 12 and 13 in the upper left of the TJA 1043, should be the CAN high and low. We can actually even see the depopulated transceiver has vias going to the harness as well. A quick look at the NXP website will give us the TJA 1043 datasheet, so we can actually confirm the CAN high and CAN low lines between the transceiver and the wiring harness itself. Now we've got it wired up. DuPont wires go over the pins in the wiring harness really easily. We've pinned out the 2 CAN channels and powered it up to a bench supply. The object of this test is to make it accessible, so we'll use a Raspberry Pi with the CAN-HAT Duo interface. I've put in the termination resistors, which would normally exist somewhere else in the vehicle. I wouldn't recommend using a Raspberry Pi in a vehicle. Typically they can get overloaded with a lot of interrupts and a lot of overhead, but in this case for bench testing single ECU, it's definitely not a problem. I didn't use any standoffs, so to prevent any shorts, I used a sheet of paper. We can SSH into our virtual vehicle using the Ethernet port on the Raspberry Pi. And this is the final setup. First thing we do is send a message over to the ECU, and we can actually see the ECU respond. Unfortunately, after about 6 or 7 seconds, the ECU stops responding. It only got one message, so it came up, did its startup sequence, didn't see any traffic, and went back to sleep. We can send that message again. It got the interrupt, woke up, sends out some traffic, decides there's nothing to do, and goes back to sleep. So this is obviously the issue that many people have when they're trying to bench test an ECU. How exactly do we get the ECU to run because it's not in the vehicle and receiving all the data it actually needs? If we look at the traffic that the ECU is sending out, we notice that there's a standout message. It says 42B. And the payload of 42B is FE2B04. Sometimes the FE becomes FD, and if we scroll down to where it starts to sleep, that FD-FE pair goes to an FC. And the 04 actually turns to an 84 is the last 42B message that comes out of the device. This is very, very indicative of AUTOSAR network and state management in that we can see the ECU state come awake, has nothing to do, waits last call, then goes back to sleep. With some fuzzing, we can actually find the message. It's being transmitted now in the lower left-hand window, and on the lower right-hand window we see that the ECU is more than happy, sending out a lot more traffic than it ever did previously. Sending out some diagnostic messages on the other bus in the upper left-hand window, we notice that the ECU doesn't necessarily respond to the broadcast IDs, but if we do some fuzzing, we can find the ID, whip up a little get VIN script, execute it, and pull the vehicle's VIN number out of the ECU. So this is the 2022 Dodge Ram that the ECU came from. Turns out we didn't need the vehicle at all. And doing a little bit more digging, we can find things like the ECU version, model number, software, etc., etc. And there's a lot more other information related to the vehicle in there. We can also look at the cellular module. It does have a storage device and an ARM controller there. The JTAG or memory controller appears to be accessible through some test pads. Now that the device is running when plugged into a PC, the USB port enumerates as a couple of audio devices and a couple of Ethernet devices that are prime for exploring. Stay tuned and we'll see what happens with the cellular module and the Ethernet devices. And if you have any questions, concerns, or comments, just leave them below.